using the dot product to find the angle between vectors. The equation we use to find the angle between vectors is we set our dot product between those two vectors equal to the magnitude of the first vector times the magnitude of the second vector times cosine theta AB. Theta AB is the angle between the first and the second vector. So if we were to have two vectors, a vector A and a vector B, the dot product between vector A and B, like units, getting grouped together. So we would take our x or I term, multiply those two factors together, add that to our j or y term multiplied together, plus our z or k term multiplied together. So it would be ax times bx plus ay times by plus az times bz. Note that the dot product is a scalar value, meaning it is just a value. It does not have any direction. So we don't want to have any of those unit vector signifiers in our dot product resultant here. To find the magnitude of each vector, we're going to take the square root of the sum of the squares, or the square root of the x component squared plus the y component squared plus the z component squared. We're going to do that for each of the vectors. And then, like I said earlier, theta AB is the angle between vector A and vector B. If we take a look at this example, where vector A is 1i plus 2j minus 1k, or 1, positive 2, negative 1, and vector B is 3i minus 1j plus 2k, or 3, negative 1, 2. We can rewrite our equation that the dot product equals the magnitude of each vector times cosine theta AB, where theta AB is the angle between those two vectors. We can solve for theta AB in that case. So theta AB, if we rewrite our equation, theta AB equals the inverse cosine, or the arc cosine, of the dot product divided by the product of the magnitudes, the magnitude of A times the magnitude of B. So the dot product of A and B is going to be the x components multiplied together plus the y components multiplied together plus the z components multiplied together. So in this case, the dot product between vector A and vector B is 1 times 3. Those are our I components. That's our I components multiplied together, plus 2 times negative 1. That's our j components multiplied together, plus negative 1 times 2. That's our z components, or our x components, multiplied together. So in this case, that dot product ends up being negative 1. To solve for our magnitude of our vector, we're going to do the square root of the sum of the square, the x component squared plus the y component squared plus the z component squared, then take the square root of all of that. For our a vector, it ends up being the square root of 1 squared plus 2 squared plus 1 squared. Any negative value squared is we're going to lose our negative, right? The magnitude of b ends up being the square root of 3 squared plus 1 squared plus 2 squared, that ends up being the square root of 14. So if we go back to that rewritten equation where theta AB equals the inverse cosine of the dot product between A and B divided by the product of the magnitudes, we can then find that theta AB equals the inverse cosine of negative 1 divided by the product of the square root of 6 and square root of 14, and that brings us to an angle of 96.26 degrees.